today I'm going to teach you about indices in mathematics grade 12. Sadly, this topic is only found in paper 1. Now, before I can teach you what you're going to find, let's see if we can talk about a few things that you need to understand before we can solve this. So, the concepts you need to know. Number 1, by the way, these concepts I'm giving you are the so-called rules of indices or laws of indices. Only I'm not going to talk about everything, but just what you're going to need, the 6 concepts that you're going to need to solve the examination paper. So the first one is this. When you are given a number, let's say a is a number to the power 0, answer is 1. So any number to the power 0 is 1. Then number 2, any number to the power 1 is the number itself. For example, in this situation, if we have 9 to the power 0, the answer is 1. In this situation, if I have 10 to the power 1, the answer is 10. Then if you have, let's say, a to the power 3, this means we are multiplying a by itself 3 times, like this, a by a by a. Example, if I have 2 to the power 3, this means 2 by 2 by 2, which is 8. Then, if you have, let's say, number 4, a to the power 3 over 2, in this situation, we can introduce this root sign. We get the a, put it inside. The number that is at the bottom here comes here. Then this number up here goes up there. So this can be transformed into this. A small number, the number at the bottom, the denominator comes here, the numerator goes up there. Then for number 5, if say you have a to the power 1 over 2, now you have a negative number like that. A negative power. How do you get rid of the power? You can do this. A, so the a comes as it is with its power, then the negative becomes like that. For example, in this situation, if say I have 9 to the power 1 over 2, like that, this is going to be 1 over 9 to the power that. Forgot to give an example here. For this one, let's say I have 8. I'll introduce this. The 2 will come here, the 8 will come here, and the 3 will go up there. Then the last one is this. If say you have a over b, then everything to the power 3, the power 3. The 3 applies to both the a and the b, like this. A to the power 3, b to the power 3. So with these simple laws of indices, let's see if we can solve the examples you're going to find in the exams. Example 1. By the way, the questions on indices will always say evaluate, as you can see for question 2 and question 1. So question 1, evaluate this. For this one, there's a law that I forgot to show you, and this law works like this. Say for example, you have a to the power 3, like that. So the a to the power 3 is inside, and outside you have the cube root. As long as these are the same, this and this can cancel to give a. Let's see if we can work this out. So here, we can do this. H1. Here, I'm applying the law that this applies to the 16 and to the H1. The fourth root applies to the 16 and the H1. That's why I've done this. Then on the inside, I can make 16 a power of 4, H1 a power of 4. How? Like this. 2 to the power 4 is 16. 3 to the power 4 is 81. And we close them off to the power 3. These 4 and this can cancel. These 4 and this can cancel. And this will be 2 over 3. Everything to the power 3, which is equal to 2 to the power 3, 3 to the power 3. We are using this principle, this law, which shows that the 2 applies both to the A, like this, and to the B, like that. So, at this point, 2 to the power 3 is 8, 3 to the power 3 is 27. How? 2 to the power 3 is 2 times 2 times 2, which is 8. 2 to the power 3 is 3 times 3 times 3, which is 27. So it is the final answer. Then number 2, evaluate this by that. So the first part, we are going to use this law, which states that any number to the power 0 is 1. So if I get this and write it here, times minus 2 minus 3. This number to the power 0 will be 1 multiplied by this part. I have minus 2 to the power minus 3. So to get rid of this part, I can use this law. The minus will be 1 over, then this will be 8 to the power 3. So this will be minus 1 over minus 2. Then this will be positive like that. Then from here, this one will come as it is, or maybe you can just directly put a 1 under here so that I can multiply 1 by 1. So 1 by 1 is going to give me 1 over 1 by this. I get the same thing to the power 3. And this is equal to 1 over this to the power 3 is as good as this times this times this, which is minus 2 times minus 2, which will give me 4 times that minus 8. So that's your final answer there. Let's go to number 3 and 4. Questions 3 and 4. So 3 looks like this. So as usual, what are we going to do here? We're going to distribute this power like that, using this law. The 3 will apply to the A and to the B like that. So this by that, this will be 8 to the power 3. Then this with this, 27 to the power 3. Then from here, we are going to use this A. Let's say 1 over 2 is equal to the A inside, the 2 can come here, and then everything will be the power 1. You can use the same law here. I'll get the 8. 3 will come here, and then the 2 will be up there. Same with the 27. The 3 will come down here, then the 2 will be up here. Then here, to get rid of this cube root, what I can do here is express 8 as the power of 3, which is 2 to the power 3, that to the power 2. Then the same here, then 7 as the power of 3, is 3 to the power 3, then the 2 up there. Then this will go with this, even with 2 to the power 2. This will go with this, 3 to the power 2, which is equal to 2 to the power 2 is 4, then 3 to the power 2 is 9. Then this part, 8 over 27, everything to the power 1 over 3. The 1 over 3 applies both to the 8 and the 27, the numerator and the denominator. So this will be 8 to the power 1 over 3, everything over 27 to the power 1 over 3. Which in this case, let me see if I can use this part because I don't think this part will suffice. So this will be 8. I introduce this, the 3 will come here, making it a cube root, and then the 1 will be up there. LCM down here. The 27 will be there. 3 looking at the cube root. Then expressing 8 as the power of 3, this is 2 to the power 3. Close it off. 27 will be 3 to the power 3. Close it off this, close with this, remaining the 2. This goes with that. And like that, we are done. Okay, questions 5 and 6. So 5, 2 to the power 2 by 3 to the power minus 1 by 2 to the power 0. So this 3 to the power 2 is 3 by 3. Then this 3 to the power minus 1, we can use this. A to the power minus 1 is equal to 1 over a to the power 1. So this can be expressed as 1 over 3 to the power 1. Then times 2 to the power 0. Any number to the power 0 is the number 1. So this will be 1. 3 times 3 will give us 9 times 1 over 3 to the power 1. Any number to the power 1 is a number itself. So this will just be 3 times 1. Now, to equalize this, to make this look good, I can put the 1 down here and the 1 down here, so they all have a numerator and a denominator. 9 times 1 times 1, 9. 1 times 3 times 3, 3. 9 divided by 3, 3. And this part, this is 3 over 2, the power minus 2. So we can do this, I think, 2 ways, but one way is to directly do this. Any number to the power, in this case minus 2, this will be 1 over a to the power 2. So here we can write it as 1 over to the power 2. But over also means division. So this can be 1 divided by 3 over 2 to the power 2. Let's see if I can use this part. So this is 1 divided by this 3 over 2. The 2 applies to the 3 and to the 2. So this will be 3 to the power 2 and 2 to the power 2. Then this is 1 divided by 3 to the power 2 is 9, 2 to the power 2 is 4. Now, for me to deal with this situation, the 1 will come as it is, or I can put a denominator down here so that it's equalized. Then we have fractions in both situations. Then this division sign, then to multiplication, and 4 over 9. This part switch, the bottom part goes up, the part goes down, like that. And 1 times 4 is 4. 1 times 9 is 9. Question 7. So this is 5, 3 times 1 over 5 squared. So we can do this 2 ways. One way, a way I didn't show you, if you have a to the power b over a to the power c. This can be a, then you just subtract the powers like this, b minus c. If you are multiplying, just add the powers. So here, you can say over 1, this times this is 5 to the power 3, over this times this is 5 to the power 2. Then here, you can just get the base, which is 5, and then the powers 3 minus 2, which is 5 to the power 1, which is just 5. Or, right here, I can do this, 5 to the power 3 times 1, then this times this, 5 2, this 5 to the power 3 can be 5 times 5 times 5, then times this one, then this is 1 times this is 5 times 5. Then at this point, 1 will cancel with 1, this 5 with this 5, this 5 with this 5, and remaining with just that 5. Then number 8, we have 9 and to the power half plus 1. So for this one, we can use this a to the number 2 to the power 2 over 3. The 3 comes here, a inside, everything to the power 2. So here, I can do this. 9 inside, 2 comes here, the power 1 plus 1. Here I can express 9 as a power of 2. So this is going to be 3 to the power 2. Then here is the 2. 1 plus 1. So this will cancel with this, and I have 3 to the power 1 plus 1, which is just 3 plus 1, which is 4. 9 and 10. So for 9, I have minus 3 squared plus 3 squared. So for this one, minus 3 to the power 2. This one is going to be, how best can I explain this? I need to try this in a calculator. Minus 3 squared and this. You notice that it gives different answers. But in this situation, what I'm trying to show you is that the minus is not affected by the square. So this is like 3 by 3. The minus is outside, and then I have 3 by 3. Then this is just 3 by 3. So 3 by 3 is going to be minus 9 plus 3 by 3, which is going to give us 9, and this will give us 0. Minus 10 plus 9, it's like cold and hot. They are going to give no difference in temperature. They're going to give you lukewarm water. So these will just cancel each other out like that. Then that one, 64 over 125. So here, the 1 over 3 is applying both the 64 and the 125. So this part will be 1 over 3. Then here, 1 over 3. Then we can express this like this, 64. The 3 comes here. The 1 goes up here. Then again down here, 125. The 3 comes here. The 1 goes up there. Then we express 64 as a power of 3. 64 as a power of 3. What number can that be? 64 as a power of 3. 125 as a power of 5. 125 as a power of 3 is 5 to the power 3. Now for 64, 8 times 8 is what will give us 64. So maybe this can be 4 to the power 3. And therefore, we are going to have this cancel with this with this, giving us 4 over 5 to the power 1 to the power 1. But the ones don't matter as much, they are inconsequential. So that is your final answer. So these are the questions you are going to meet in paper 1 under indices.